Morning, everybody. Thank you for joining us this morning. We're going to start with a couple of introductions, give a little bit of background, and then we'll get tucking straight into the content. So I'm Stuart. I'm one of the client managers at Northdoor, and I look after a lot of our insurance and financial services relationships. I'll let John give a quick intro.
Yeah, hi everybody. I'm John Smith. I'm the EMEA CTO for Veracode. I look after the solution architect team across EMEA and help with talking to customers.
Great. And so Veracode are one of our partners here at Northdoor. And this kind of session today is born out of a session that John and I attended probably about 6 weeks ago now at Lloyd's Insurance, where John and I were talking about the inherent risks of software, particularly in the insurance industry. And when we were there, and I won't steal too much of John's thunder, but John was talking about an annual report that Veracode complete, which is the State of Software Security report. And born out of that report is a financial services vertical, which looks obviously more specifically at the financial services industry and benchmarks that against other industries. And so what we thought is, as a follow-up to that session at Lloyd's a few weeks ago, we would drill down a bit more specifically into the financial services industry and give you some insights that Veracode have got. So without further ado, I'll hand over to John and he'll walk you through some of the findings from that report. Final thing, if you do have any questions today, there's a chat window that you can pop any questions in, and if we've got any, we'll get to them at the end. But that would be it, and I'll hand over to you, John.
Great stuff. Thanks, Stuart. Yeah, so let's get into the content. I will click on magic buttons and you should be able to see the slides now. So as Stuart said, the State of Software Security report, this is a report that we do on an annual basis. We as an organization, Veracode, have a huge amount of data to mine. We test all of our customer software. We're a software as a service vendor, so we have visibility into some of the data, anonymized data that we get out of those tests that we perform. And it helps us to build up these big pictures of what's happening in software security. What are we seeing as prevalent? What are we seeing as declining or increasing? How are the trends affecting us? And because this is volume 12, the 12th year that we've done this, we do have a lot of historical data that we can go off as well. So we can really start to see how trends have developed over longer periods and where there have been bumps in the road or variations along the way. So the big themes that we're going to go through in this session, we're going to start off with a bit of a look at how software development has changed over the last decade or so. And we're using some of the data from the report to help us understand how that picture has altered over time. A really hot topic over the last year or two has been to do with third-party components, particularly open source components that are used in software and the implications of that. We saw the executive order last year where President Biden has been insisting on software bill of materials being made available for software sold into US government. So we'll drill down a little bit into that topic. And then we'll look at how actually your own code problems, the flaws in your software, how that's been changing over time, what's been changing, what's been developing there. And then the final section is where we drill into and how does financial services as an industry compare to other industries. And again, as a software as a service vendor with customers in pretty much every industry segment all over the world, we've got the ability then to sort of slice and dice that data a little bit to look at how it affects particular industries and how particular industries are comparing. And we can try to draw some conclusions from that. It's not always easy to draw firm conclusions, but we'll look into that a little bit. So let's get into the meat of this then. How has software development changed? And if you're watching this and you've got any involvement at all in the world of software, I don't think this is going to come as a huge surprise to you. But if we take the context, first of all, what we have seen is that whereas 10 years ago, typically we were seeing maybe five or so new applications being scanned each week, What we're seeing now is more like 17 applications being scanned each week, and this is per customer. So we're seeing, you know, a pretty huge growth there, an awful lot of different things that customers are considering to be applications. They're being scanned separately, you know, at a higher and higher rate. And that's, as I say, it's not a huge surprise to me. The world of software in enterprises is an ever increasing thing. Software has truly eaten the world and is continuing to digest it. And so we're seeing a huge amount of software being tested. What's kind of interesting to me is that we've also been able to drill down and see, well, it definitely looks like we are seeing the rise of microservices. This is a journey that Veracode ourselves have been on. So we've been re-architecting our platform and re-engineering the back end of things to be a microservice oriented architecture. It helps us to move faster in developing new functionality for our customers, and it helps us to create a more stable and maintainable environment. The thing that we've picked out here is that whereas in times gone by where we were looking at much more monolithic applications, what was clear was that we would see multiple different programming languages in an application. So we would see the front end, possibly some JavaScript there. We would see the sort of enterprise application end of things, maybe some Java or some .NET or something like that. And we may also see sort of some back-end service elements that were written in other programming languages. What we see with microservices is this funnels down to really just a smaller piece of code with a single purpose, and it tends to be oriented in a single programming language. And you can see that on this graph, that the thing we're seeing here is that, well, I think if we go back to 2018, about 20% of applications would contain multiple programming languages. Through to this year, it's down to around about 5%, a little bit less than 5%. So we're getting through to those much more focused, dedicated pieces of code performing a single function, which is really what's a good indicator of a microservice architecture. We've also layered on here another line that shows you Google search interest in microservices as a search term. And obviously you can see that that's been rising dramatically ever since about 2014 and continues to be a high level of interest there. So we've absolutely seen that software architectures are trending towards these smaller, more specific pieces of code, the world of microservices. The other thing, or another thing that we have seen very clearly is to do with how often software is being tested. And you can see here across our different testing technologies and testing approaches, whether it be manual penetration testing, dynamic analysis, static analysis, and indeed software composition analysis. What we're looking at here is the amount of time that goes between scans taking place. It's a logarithmic scale, so it creates a slightly skewing effect here. But if you look at something like dynamic analysis, where back in 2010, we were looking at maybe 100 days between scans, and now we're looking at less than 10 days between scans as a typical scan cadence, an average scan cadence. Same goes for static analysis. That's down to almost scanning every day for most software. And SEA agent actually started pretty low and has continued to drive lower. And what we're seeing there is that analysis of the software, doing security testing, is no longer being treated as a let's wait until we're doing a release and then let's do a test then. It is something that's being embedded in the software development process. It is becoming an integrated part of the way that software is being delivered. And so we're seeing a much higher rate of scanning, a much lower cadence between scans. So that's great news, I think. One of the reasons that I think it's great news is that when we look at data from last year, and we were looking really at what things influence how much remediation, how many flaws actually get fixed in software. One of the things that you can pick up through here is that a steady scan cadence, scanning frequently through an API, all of these things are factors that drive a greater level of remediation. More stuff gets fixed, and it gets fixed faster. Compared to the things in the bottom half of the graph here, we're looking at things like larger organizations, larger applications. They're sort of nature aspects. They're things that you can't really easily change about your software. But things like frequent scanning, doing it through an API and doing it in a steady, regular rate, that really can have an impact. It's also worth noting here that combining different scanning technologies also has a really positive effect on remediation. That was what we found last year, and the findings continue to be true. So this whole section, how has software development changed? Key trends are, we've seen a trend towards microservices, smaller, more manageable chunks of code. We've seen a trend towards more frequent scanning, and we are also seeing trends towards more combination of scanning techniques, and that driving better rates of remediation. So let's move on and spend a little bit of time talking about third-party components, dubbing this section the software bill of mistakes, and let's drill down into that. So some things really haven't, I guess, I don't know whether this can be termed an improvement or or not, but the amount of third-party code involved in an application continues to be really quite high. There are some languages where we're seeing a downward trend. So for example, in JavaScript, more and more stuff is being rolled into the language, and we're seeing less of that. In the world of .NET, we saw a big jump in 2020. That was to do with the, I think it was .NET Core 5 or something like that. .NET 5 had a big impact on how much functionality was built into common libraries and how they could be used. So we saw a big step change there. In the world of Java, it continues to be an enormous amount of third-party code. I mean, of all the programming languages, you can see there that Java is the most third-party ecosystem, I think, that we've got in the world of software. There's generally a good level of third-party code being used across all software. And what does that mean? Well, it's interesting to look at, are people then using different libraries all the time? One of the things we've noted is that actually popular libraries tend to remain as popular libraries. Now, I can see that on this screen, this is going to be a bit of a screen test, an eye test for you here to be able to read these things. But when we look at the world of Java, for example, Apache Commons is an incredibly widely used set of components. It provides a huge amount of sort of base functionality that you can do all sorts of stuff with. And it continues to be right at the top of popularity. In fact, if anything, its use has expanded. Across all of these different programming languages, with the exception of JavaScript and Ruby, what we tend to see is that popular libraries just get more popular. They get more widely used. Now, it's worth mentioning that Log4j is an enormously popular library in the world of Java. It's probably become a bit less popular this year, although actually moving away from it completely is going to be pretty challenging for most organizations. It's so widely embedded. The good news is that there are fixed versions of Log4j available, and so people can move on to that. But it does highlight the fact that there can be a concentration of risk that happens where a particular component becomes hugely popular and becomes hugely widely used. And then if a vulnerability is identified in there, that is suddenly a real fire drill for organizations to do something about it. So if we look at flaw prevalence when it comes to open source libraries, just move the slide on if I can get the click to work. There we go. When we look at flaw prevalence, I guess there's some pretty good news to be had here. So when we look across all different programming languages, when we net this all out, if we go back to 2017, nearly 35% of all libraries used would have had a known vulnerability in them, a known flaw in them. The good news is that in recent years, that's actually come down. It's now just under 10% of all libraries being used in software having known vulnerabilities in them. And I think there's a couple of factors at play there. I think that developers of libraries have become a little bit more savvy, a little bit smarter, a little bit more aware of the impact of security issues. So there's been a little bit more focus on improving the security of those components. The other thing that I think has been noticeable is that over those last 5 years, the world of software composition analysis as a technology has become much more widespread. It's been used in a much more widespread way across industries. We certainly see that most organizations are either using software composition analysis or are absolutely looking into how they can bring software composition analysis into their software development process. So it's not to say it's a solved problem. It will continue to be an ongoing problem because software does continue to have vulnerabilities in, whether it's an open source component or whether it's your own first-party code. But the good news is that that is a trend that is heading in the right direction. And we should absolutely applaud that. So let's move on now and talk about actual vulnerabilities in your own code or your own software. Let's focus in on your software a little bit. And there's all sorts of things to call out here. I think the first thing that I would call out, and the title of this section, "The Flaws of Yesterday Are Still the Flaws of Today." What we tend to find is that the types of vulnerabilities that we're finding today are the same as the types of vulnerabilities that we were finding 10, even 15 years ago. We may be finding slightly less of them. And I think you can see from this chart here that there is a general downward trend, moving from in the region of sort of 80 to 90% of applications having some kind of flaw, if we're looking at the any flaws line, down to more like 75%. So we are seeing a line in the right direction. Kind of pleasingly, I think the most worrying stuff tends to be the high severity flaws, and that is the lowest line here, and it's one of the lines that's indicating a really good downward trend. So down from more like around about 40% down to less than 25%. So really good progress there. Again, I'd love to say that that's job done. It of course isn't. If we've still got in the region of 25% of applications coming into us, being tested, finding high severity vulnerabilities in them, high severity flaws in them, that's still 1 in 4 applications that have a problem that needs to be fixed. So there's still room for progress here, still room for improvement. But I take heart from the fact that the direction of travel is in the right way. Now, if we look at the types of things that we're finding in software, and of course, different types of scanning technologies, different types of analysis will, by their very nature, tend to find different types of flaws. There are things that static analysis is really strong for. There are things that dynamic analysis is really strong for. We can take a little bit of a look at this, again, probably a little bit of an eye chart. If we go through these one by one, so for static analysis, the types of flaws, pretty much most things are trending downwards here. There are some notable exceptions. JavaScript and Java have an ongoing challenge here. JavaScript in particular has some challenges with identity management, and we also see that credential management and authentication issues are tending to trend upwards over time. And I think one of the things that probably drives that is that we're in a more connected, a hyper-connected world. Software itself is making use of more external APIs, web APIs, as it does its work. And so there is a greater challenge of managing identity and managing credentials to be done in any sort of software. So there are things that definitely continue to require focus. Credentials management and identity related things are definitely top of the list for static analysis. When we look at dynamic analysis, the top issues that we're finding with dynamic analysis really don't overlap that much with static analysis. So things like server configuration and insecure dependencies, those are things that you tend to pick up with dynamic analysis, but you don't really tend to pick up with static analysis. And I think that again speaks to the fact that there's a lot of value in combining different testing techniques. It helps you to gain, first of all, a more holistic picture of the security of your software. It also, we know from statistics, we know from the data that it helps to drive a greater rate of improvement in the software. We see issues being fixed faster. And if we've got that combination, that overlap going on, that really helps just to make your software more secure. Then moving on to software composition analysis. Well, you get a huge breadth of different types of issues being found here. Of course, some of them are being reported by doing things like static and dynamic analysis technologies. Some of them are through more human-based analysis, whether that be penetration testing or code reviews by the people responsible for the project. So we get a pretty broad range of different types of issues being identified and reported here. Once again, we're tending to find that there are some languages that have particular effects going on. For example, in Java, JavaScript, and Python, we're actually seeing clear declines. We're not particularly seeing those declines in .NET and C++, for example. So there are differences between the languages and the different ecosystems of third-party components. But as a whole, again, SCA, combining the different technologies gives us that broader picture of what's actually going on in our software. Remediation trends are really important. And I say that because I very much doubt that anyone on this call has a software security or an application security program purely for the purpose of identifying what vulnerabilities exist. The whole point of doing software security, application security work is to actually improve the security, to reduce the risk that you have in your software. So looking at remediation trends is really quite important. And one of the things that we've found is good to focus on when looking at these trends is looking at the half-life. So looking at how long it takes for half of all the vulnerabilities or flaws being identified by a particular type of technology, how long does it take for them to get actually resolved? And you can see here on this graph, if we look at the half-life, then for software composition analysis, it's actually pretty bad. It's 397 days for half of the flaws to actually be closed. Whereas if we look at dynamic analysis, we come down to more like 143 days. So, almost a third of the time to reach that half-life level. And static analysis is somewhere in the middle. I guess the question we have to ask ourselves is why is this the case? And I've got some ideas for why some of these things are faster than others. In particular, with dynamic analysis, I think the audience for dynamic analysis tends to be slightly different to the audience for static or software composition analysis. The audience typically for dynamic analysis is the security, the SecOps side of the organization. And it also is, by its very nature, dynamic analysis is showing you exploitable vulnerabilities because the testing is done from the outside in. It's done as a direct manipulation of the application. So I think what we tend to see is that where vulnerabilities are being identified through dynamic analysis, they're very much being leapt upon and something is being done about them really quite quickly. Software composition analysis at the other end of the spectrum, I think part of what we're seeing here is the challenge of actually upgrading components in software. We've identified before that there's a trend in the world of software that you bring in a component to solve a problem. So you bring in an open source component to your code base. And once that problem is solved, there's a tendency to now forget about it and move on and not really consider that maintaining that third-party component that you've brought in is actually part of the ongoing maintenance of the software. So there's this kind of use and then forget about it culture that develops around open source components. The other challenge there, of course, is that whereas with flaws that are identified through dynamic analysis or through static analysis, where typically you yourself have control over the code that you're testing, with open source components, the only option you have is to upgrade to a newer version or a version that has either less or ideally no known vulnerabilities in them. And so your ability to influence things is perhaps slightly lower. You can't fix the code itself, you have to make changes. And if making a change to a newer version of that component involves changes to that component's APIs and behaviors, it may mean that it's a bigger job to do. Nonetheless, what we're seeing here is that, as I said, dynamic analysis, really quite decent performance from a remediation point of view. Less good for static and less good again for software composition analysis. However, the good news is that whilst for dynamic analysis and for static analysis, that half-life hasn't actually changed very much over the last 5 years or so. What we're absolutely seeing is that the half-life has been improving for software composition analysis. So if you imagine that previous slide back in 2018, it was actually even worse. Software composition analysis was really slow to get remediation. Yes, it's still slowest, but it is improving. It's trending in the right direction. I think, you know, if you're looking at this and you're thinking about your own software, a clear takeaway here is that you need to make sure that you have both the analysis technology in place in your organization to identify open source vulnerable components. And you also need to make sure that there is the right incentives, the right metrics being put in place to ensure that the remediation and the updating of third-party components is being driven to a higher speed. So then we talk about the capacity to fix over time. And what we're trying to get to here is how much capacity there is in a given month for effort to go into fixing security issues. And again, we've broken this out according to the we've broken this out according to the different analysis technologies. And again, I think there are factors at play here. For me, for static analysis, it's a broadly flat trend. There's a very slight increase in what we can identify as capacity for remediation existing in a given month. But it's not a dramatic increase. The interesting ones for me are both dynamic analysis, which is clearly showing a downward trend, and software composition analysis, which is clearly showing that right trend. It's an upward trend, greater capacity being devoted to remediation of software composition issues. So going back to my previous exposition of why I think dynamic analysis gets fixed faster, I think that will start to play a negative impact, because dynamic analysis typically is owned by the security organization. It tends to be that outward in vulnerability scanning kind of approach. Over the last 5 years, that's been fairly positive. But I think unless we bring that in and make that part of the the development side of the house as well, then I think we're going to start to see a negative trend starting to develop with dynamic analysis. Because if it's outside of the development process, if it's outside of where the developers are living, then it's going to tend to get less focus. This is part of why we're as Veracode and I think the industry as a whole is making a big drive towards this idea of DevSecOps, of actually making security and the security team an integral part of the software delivery process. Because for as long as it sits outside, I think we're going to see a continuation of the downward trend of capacity to fix, because it's not part of the same organization. Meanwhile, software composition analysis definitely going in the right direction. We're seeing an increase in capacity around that. And again, I think that's because it's a technology that is now embraced and embedded as part of the software development process. And so that's giving the developers themselves more control, more visibility, and with that comes an improvement in remediation. So the final topic that I'm going to cover in this segment around flaws and driving remediation is to do with how can we help the development community to get better at identifying and better at fixing security issues in their code. And over the last couple of years, we've been making available to customers or selling to our customers something called security labs. And security labs is a different approach to developer education. Instead of providing you with a boring long video to sit through with maybe some knowledge check questions that come at different moments, the kind of classic e-learning model. Security Labs goes beyond that and actually spins up an environment in which you have a vulnerable application, you have the ability to edit and redeploy the code so that you can actually try fixing the code. And then it walks you through how to exploit the vulnerabilities that exist in that code. It walks you through how to go about seeing where that is in the code, and it walks you through how to go about fixing that code. So it's much more of a learning by doing or experiential learning as it's described here. What has definitely been clear to us, and now that we've had a bit of time with customers using this, we've been able to start to gather some data. What's become clear is that where Security Labs is being used by customers, by the developers, we're seeing a much improved fix rate. And in fact, the trend line that you see here actually deviates from the data set. You can see just underneath the right-hand side of the bar, you can see that there's really quite a good drop-off in the number of flaws still open after a period of time. So the thing that I take away from this is that there is no issue with motivating developers to remediate vulnerabilities in their software. I absolutely don't believe that's an issue. I've never met a software developer that wanted to write vulnerable code. And when presented with knowledge of a vulnerability in their software, I've never met a developer that didn't want to do something about it. The key things are about making sure that those developers are enabled with the information that allows them to know where there are issues. And so that's where security testing really becomes important. But also that they're enabled with the knowledge and the skills to be able to do something about it and actually fix those issues. And that's where learning technology like this really comes into its own. If we can enable the developers to know how to fix problems, indeed how to avoid introducing problems in the first place, then we're going to end up with much more secure software, much more quickly. And we're also going to end up with, I think, happier developers, because the more that developers understand what they're doing and understand what they're trying to achieve, the easier it is to gain job satisfaction from that. So I've kind of rattled through the overall findings of the State of Software Security report at this point. And the full report is available on veracode.com. Just search for State of Software Security. It's probably linked from the front page. You won't find it hard to track down the report, and it'll give you a lot more detail than I've been able to draw out in this whistle stop tour. What I'm going to do now is drill into some information that's not currently available, but will shortly be published. And it's where we start to look at different industries and how they compare in different metrics around software security. And as I say, I think the public sector report is already out. Financial services industry report should be out soon. So consider this to be a little bit of a teaser about it. So what we try to do when we compare is we look at overall metrics, we break out into different industries, and we do things like this where we can see how different industries sit in a league table over a different range of different metrics. And what you'll see across the next few slides is anything that's in blue, that is financial services. Anything that's in grey, that's other industries. In this particular one, we're breaking it down into, as you can see, manufacturing, retail, healthcare, technology, and government as a range. And to use a footballing analogy here, this is a game of two halves. It's a slide of two halves, really. The right-hand three metrics here are looking at those flaw half-lives. So we're looking at how quickly issues are getting remediated across the software. And on the left-hand side, we're looking at more the prevalence of issues being found in software and what proportion of issues actually get fixed. And to me, there's some really almost mind-bending things that come out of this. So let's start on the left-hand side here and look at the financial services industries from the perspective of what proportion of applications have any kind of flaws versus what proportion of applications have high severity flaws. And so you can see that for any flaws, actually financial services is doing pretty well. What is clear, though, is that the proportion of flaws that are being found are tending to be higher in terms of high severity flaws than they are for other industries, because we come into the bottom of the leaderboard when it looks at the high severity flaws. 18% of applications have some kind of high severity flaw in them. We also see that the fix rate, the total amount of flaws that are being fixed in financial services, is also pretty low. It's down at 22%. That is joint bottom, along with technology and, along with, what have we got? Government and manufacturing. Hard to follow some of those lines. So it's not great on the fix rate. But I suppose the good news is that there's a slightly lower proportion of, sorry, it's not good news, slightly higher proportion of flaws are high severity. So fix rate, not all that fantastic. However, there's another side to this story, and that's this half-life thing. And what we do find is that the half-lives for financial services are actually almost as good as it gets. They're in second place here, beaten only by, I think, technology. So what that means is that whilst it's not a huge proportion of flaws that are being fixed, the focus of the flaws that are being fixed is very much on those high severity issues. We're getting to the problems that matter in the financial services industry. So that's, I would say, good news. Another thing that we can draw out, and I do apologize, this slide is going to be an absolute eye test for anyone that's trying to look at it. I'm going to talk through it a little bit, and hopefully it'll make a little bit more sense to you. What we're looking at here is the prevalence of flaws, different types of flaws, what is most common across 3 different programming languages. And we focused on these programming languages because they are the most common languages used in financial services. The languages are Java, .NET, and JavaScript. And actually, you know, for financial services, Java makes up 51.5% of all applications being tested, Against overall our customer base, it's 37.5%. So there is definitely a bias towards Java in financial services. When it comes to .NET, the bias is in the other direction. It's 24.5% of applications are .NET in FS versus 29% overall. And it's broadly flat in JavaScript world, so 13% versus 14.2. It's not a particularly significant variation. However, what is interesting here is the prevalence of issues. So, for example, let's take Java as our first example, and the top most prevalent issue is something called carriage return line feed injection. It's something that facilitates things like log forging. It can facilitate HTTP response splitting attacks, those kind of things. Overall, the prevalence of that is 30.9% across all of our customer base. But when we focus in on financial services, that jumps up to 43%. And in fact, when we look at all of these most common types of issues in Java, and we look at how financial services is doing compared to the overall picture, it's actually doing worse. I really don't know what conclusion to draw from that or what to infer from that, other than to say that really there needs to be a much greater focus in the financial services industry on how we're approaching our Java code, because we're clearly not doing a great job of it there from a security point of view. Interestingly, when we move to .NET, which has a lower proportion of applications, when we move to JavaScript, which has a lower proportion of applications, the picture gets much better. In every category, we see that financial services is outperforming the market. So I'm a fan of Java. Java's a programming language that I'm pretty familiar with and have done a fair amount with over the years. I don't believe that this is a fundamental problem with Java. I think this is a problem with the prevalence of Java within financial services. And I suspect that just because there's a lot more of it, there's a lot more developers, more effort needs to be focused on getting those developers trained up so that they can write more secure code. That's where I would go with that. Moving on to dynamic analysis. Of course, with dynamic analysis, we don't know the programming language. We don't care the programming language. Taking a look at how flaw prevalence varies for dynamic analysis with financial services. Again, honestly, the picture's not that great. There tends to be a slightly higher prevalence. One of the reasons that we believe that might be the case is that the complexity of financial services applications tends to be slightly higher. And that increase in complexity is probably what's leading to a greater prevalence of flaws being found there. But as a whole, if we look at something towards the bottom here, something like code injection, just under 5% for the wider population, but for financial services, we're up to 9.3%. So it's almost twice as prevalent. The variations are less marked in other areas, but we're certainly seeing that there's a greater prevalence of flaws being identified through dynamic analysis in financial services. So then let's move on to the topic of flaw survival rates. And again, I think the thing that we should draw from this is, yes, financial services tends to be finding more flaws. Yes, there tends to be more issues identified in their code. However, what I think financial services industry does very well is fixing things. And, in particular, if you look at the lines here, we've got a gray line, we've got a blue line. And if we look at static analysis, it's broadly in line with the population. There's no significant variation there. When we look at dynamic analysis, it does better. We get more problems fixed more quickly. That first part of any of these graphs is getting stuff done quickly, and there is a much faster drop-off of issues being found for dynamic analysis than the wider population. And similarly, for software composition analysis, it's a less marked trend at the beginning, but overall, we are seeing that the FS world is remediating issues just that little bit faster than the wider population, which obviously is good news. Could it be faster? Absolutely. Should we be seeing half-lives that are in the region of, you know, the 1 year mark? No, we shouldn't. But that's where we are. And at least financial services is leading the way on doing things a little bit quicker there. And so we come to the final slide and the final bit of data that I've got to present for you, which is to do with the proportion of libraries that are being used in software that have known vulnerabilities in them. So this is identifying open source vulnerable components. If we look at financial services compared to the rest of the world, the rest of the population, well, let's walk through it. So the world of .NET started out back in sort of 2019, started out in a pretty bad place, a much higher proportion, although keep in mind that the percentages here are still pretty low. We're still talking about, you know, in the region of about 7% back in 2019. What we have seen is that over the last couple of years, that's normalized back to be broadly in line with the rest of our customer base. And in fact, you know, the kind of numbers that we're looking at here are really very, very low. .NET, from a vulnerable libraries point of view, is a really good programming language to operate in. You know, we're looking down at the sort of under 3, maybe 2.5% of vulnerable libraries being used in .NET applications. So that's a great place to be in. Java, if we look back over the last 5 years in this case, we can see, well, first of all, we can see the percentages are overall much higher. You know, we were starting off at more like 27% for Java, going up to 30% in sort of mid 2017. But it has dropped off a cliff, and overall, financial services is doing, or started off doing, better, and is now broadly in line with the wider Java community in terms of those open source vulnerabilities. When we look at JavaScript, it's kind of a middle ground, but we are seeing that financial services possibly performing slightly better, but again, broadly in line with the downward trend in terms of vulnerable libraries being used in software. So to sum up all of the stuff that we've talked about there, is financial services doing dramatically differently to the rest of the industry? Well, I think there are some areas where there are noticeable differences. I do think that the rate at which the FS industry goes after vulnerabilities once they've been discovered is really quite good compared to most other industries. I would guess that that's in part due to regulatory pressures, but I think it's also due to the sort of sense of responsibility that exists in the FS industry. So I think that's pretty good. I think there are some legacies that exist of technologies, in particular Java. The notable prevalence of Java within the financial services industry does have an impact, and it means that when things are bad, when bad things happen to Java, like for example the Log4j issues that we had earlier this year, that is going to be a big hit on the FS industry. So staying on top of maintaining a good inventory of components is going to be pretty key there, and making sure that the army of Java developers that you've got are actually being enabled to do better secure software development, I think is going to be pretty key. Those to me would be the key things that I would pick up on there. Stuart, was there anything that that you noted from that you think's worthy of a comment?
No, I think you've covered it pretty well, John, to be honest. I mean, all I was going to say is for anybody either watching today or potentially watching the recording, you know, if you have any further questions, just don't hesitate to get in touch with me. And, you know, we can always set up a one-to-one session with Veracode to delve into your business more specifically and look at your yeah, look at your situation more clearly. So we're always happy to do that. So yeah, just get in touch if you do have any questions.
Absolutely. All right, great stuff. Well, I think that's us done for this session, Stuart. Let's
agreed.
Draw a line there.
Great. Yep. Thanks for joining, everybody. Talk soon.
Thanks, everyone. Bye.